from chapter 2. Again, chapter 2 was a while ago, so we're trying to go back in time and remember all the things that happened, even stuff all the way back to August. Number 1 is asking you to plug in A plus H. So I did that. Specifically, and let me get a highlighter out. So this part where I plugged in A plus H is this. That corresponds to that. And then it said, okay, take minus f of a. Okay, so this corresponds to this. There's my f of a. There's the minus that was in between them. And then let's divide it all by h. So this is like an evaluation problem because you're plugging stuff in and you're evaluating, you're figuring out what it equals. Remember that when you're multiplying this set of parentheses, a plus h squared, that you actually need to FOIL it out, right? It's a plus h times another a plus h. So you end up with a squared plus 2ah plus h squared. And then when you multiply it by 5, that's where these numbers came from. So 5a squared and 5h squared, but because you have that 2ah as your middle term, that's why this is a tie. Be careful. I often forget that 3 is there because I'm like, ooh, I did all the multiplication, and then I forget about this little 3 that I didn't have to. So make sure you don't forget about the 3. Make sure that you distribute the negative into both things in here. That's another common mistake that people make. You should get a lot of stuff to cancel out. And so you should have 10ah plus 5h squared all divided by h. So basically I took an h from each to get my final answer. And believe it or not, and we talked about this way back in chapter 2, this is setting you up for when we get into some calculus stuff and start doing derivatives, as does number 4. So there's a reason that they're throwing in these a plus h's and dividing by h. Like, it seems random when you look at it, but there's a method to their madness. Like, there's a reason. Okay, number 2. I looked at my denominator and I saw that -1 and -8 would be really bad for business, right? Because it would make it undefined. In the top, I realized that x had to be greater than or equal to 0. So you have to kind of combine all those things together. And so truly, it's going to be 0 to positive infinity because it can't be -1 or -8, but that already exists in that region that we shouldn't live in anyways. If you forget to solve this algebraically, I keep talking about like having a plan A and a plan B for problems. Could you graph this equation and see where it exists in terms of x? Okay, so that would be my plan B. Plan A would be just to solve it algebraically because I think that's faster. So that would be my plan A, and then switching to graphing would be my plan B. And that's true of any domain and range problem. Okay, I chose yellow. Oh, that doesn't show up that badly. Okay, I don't hate my choice that as much as I thought I did. So for number 3, that's a piecewise function because it comes in pieces. Remember that we always graph starting with the number they give us. So both of my t-charts start at 1. One of them, however, is going to have an open circle because it doesn't actually truly exist at 1. So this one, it says plug in values less than or equal to 1. So I plugged in 1. What's less than 1? 0 and -1. I plugged them in and got out these values and I graphed it. This one, I plugged in values bigger than 1, but I started with 1. So remember, that's where your open circle goes, is that spot that doesn't really exist. And then I graphed the rest, and that's where that yellow part came from. Is that good for that one? Now, remember what that would look like on a multiple choice test. If I gave you, so this could go one of two ways. I could give you the equation, and then the multiple choice would be different graphs, and you pick the correct one. Or I give you the graph, and you have to tell me what equation it came from. Okay, those are the two ways it could be. So remember, you can't actually like graph on a multiple choice test. Does that make sense? So I just want you to think about what that problem's going to look like. Average rate of change. Anytime you see rate of change, it's always slope. Always, always, always. So it's y2 minus y1 over x2 minus x1. Or as I wrote it, change in y over change in x. Now, if I plug in a, I get 3a plus 6. If I plug in a plus h, I get this. And then if I plug it into the slope formula, I get that. And Sawyer, what did you realize is true about this number?
It's the same as the slope.
Oh, it's the same as the slope. Could I have just looked at the equation and saw the slope? Yes. Why on earth would I do all this work? Again, because down the road in chapter 13, when we learn about derivatives, which is the basis of calculus, this is how we're going to be calculating it. We're going to be finding a rate of change, and we're going to be finding it using this formula. So that's why they taught it to us this way. Will this always be true, that it'll be the number in front of x if it's a line? Yep. So if it's linear, it will always be that value. Am I going to even know how you solved it on the test? No, because I'm not going to look at your work. So, just a little side note. Okay. But I like you to know where it comes from because it makes me feel better. Down here. Number 5. Let's talk 5 and then I'll get over into the extra stuff. Okay, so this was your equation. If you plug f of x into g of x, that x squared gets put in place of x. So that's where this came from. And then I had to find the domain. It has to stay greater than or equal to 0. So that would come from these two sets of parentheses. Remember, you can treat it like a difference of squares, even though 5 really isn't a perfect square. We can kind of like pretend it is. And so it can just go in here as root 5. And then I figured out which values worked. So I plugged in numbers to figure out which regions were the regions that gave me that solution. So this is graphically my answer on the number line. And then this is my interval notation. And honestly, I don't remember which notation you get on the exam, but it'll be one of those two. Questions on that one?
Can you go back up to number 4?
Yep. See if I can keep all that up there at the same time. And then in the also study region over here, it's going to ask you to find mins and maxes. Bless you. We did those on our calculator, yes? So you might want to take a look at your graphing calculator and make sure you remember how to find those. It was pretty easy, but if you don't remember, make sure you talk to me about it and I can help you with that. Average rate of change given a graph. So if you were given a graph, you would pick the points you were told to pick, and you would calculate y2 minus y1 over x2 minus x1. So again, I think the key there is knowing that anytime you see the words average rate of change, it's the slope formula. Problems like number 5, but with a fraction. So it wouldn't be hard to do this part where you plug them into each other and do the composition piece. For the domain, though, if you had a problem like number 5, your denominator can't be 0. So that's the note I wrote down here if you can't read this. I wrote myself a note that I would have to be careful with the domain because if I had a fraction, the denominator couldn't be 0. To find an inverse, that is when you switch your x and y and you solve for new y, is what I called it. Let me show you one of those really quick. I'm going to do it on the dot cam so we can see that before we get into other stuff. Okay, so let's pretend I want to find an inverse. Let's pretend my original equation is 3x plus 5, and I want to calculate the inverse of this. So I'm being asked to please find the inverse. Switch x and y. X equals 3y plus 5. And then we solve for new y. Again, I call it new y because a minute ago it was x, right? Not even a minute ago. So I'm going to subtract the 5. X minus 5 equals 3y. Divide by 3. Y equals x minus 5 over 3. And they may have it written like this, or they may have it separated. They may have 1/3 x minus 5/3. I don't know. But again, you should be able to find the correct answer with that information. So that would be this little last bottom thing that kind of got cut off. That's what this is. So this is this. Good? What questions do you have for me from chapter 2 stuff?
For 2, why don't we have to include -8 or -1?
Because they're already, like, they're no-nos, right? They're things that it can't be. Like, we don't want them to be -1 or -8, so they are against what we want, and they already don't live in that interval, so I don't have to worry about them. If it had been +1 and +8, then I would have had to go 0 to 1, 1 to 8, 8 to infinity, with the unions in between. Does that make sense? Okay. All right. Let's take out homework. I went a little wild on the homework. I regret that, but let's go over that, and please note tonight's is shorter. Oh wait, I don't want to turn my smartboard off.